Hi, this is Zach Ensley, and this is our solar tracker Raspberry Pi project. Now we see here is we took the project outdoors to try to get some test data in the field. As you can see, it's kind of a cloudy day out, but I think this is actually a good thing because this is like the purpose that we need this for. If the sun was shining up in the sky, then you can look up there and say, "Oh, look, hey, there's the sun." So you don't really need a device to point around and figure out where it's at. I mean, it would give you a better angle as to exactly where it's at, but this is good for cloudy days where it's a little more ambiguous. You can see it pointed up. It kind of found that pocket up there. You can see the sun kind of peeking through the clouds. But basically, we can specify a precision value and have it scan in a large area. Then once we do that, we can enhance that scan. As you see now, it's scanning a smaller area within a range around the point that it just found, and it'll finish scanning through that, and then it'll decide where the brightest point is in that range and point towards that. And Drew's going to give you a rundown of our actual interface for that through CherryPy.
This is Drew Dunham with a quick overview, or a hopefully quick overview of the SIUE Solar Tracker interface, the web interface. So here is the welcome screen that's welcoming you to the Solar Tracker, and you can specify how precise you want the tracker to move. So I'm going to go ahead and demonstrate that in this little text box right here. Allows you to put in the increments, and it's measured in degrees. So if I wanted to move the tracker at, let's do 45-degree increments, should be fairly quick, if you can see in the top corner. Yeah, and then it outputs the light intensity, the servo arm position, and the base arm position in degrees. And then it outputs an option to enhance scan, which will focus on the point where it deemed that there was the most light coming from that point. And then down below it'll output all of the data points that it took in. So I'm going to go ahead and start over and show that I can change it to a really fine amount of data points. So do 10-degree increments. That usually takes a little bit of time. See, continue scanning. And it's done. It should change. Yep, there it is, and it's detecting the light that's right above me. So, and also from this enhanced scan, you can set the actual range that it's looking at in degrees. So I can do, let's do a wide view, precision. I'll up the precision, that way it doesn't take forever. And then this automatically reads in the positions of the highest light intensity, so you don't have to change that, but if you really want to, you can change those values. So I'm going to start scan again, and then it's going to scan around that area where it found the light. And it readjusted towards the middle of that light. And then here's all of the data points. And that's basically all the features of our interface. Alright, thanks.